It came from behind our solar system, a mysterious wanderer streaking through the cosmic dark. It went behind the sun, now it has reappeared. The interstellar visitor named 3I Atlas has returned.
The night sky whispered a secret. Boldly, the 3I Atlas appeared, a mysterious visitor from the stars, hurtling into our solar system with a hyperbolic trajectory that spoke of origins beyond our sun. And now, shining through the precision of the James Webb Space Telescope's infrared eyes, faint, yet unmistakable, lights have been detected around this object. These are not mere reflections of sunlight on icy dust. They are anomalous, persistent, and puzzling, hints of something far stranger than a typical comet. Before we start, smash the like and subscribe buttons for more updates. When JWST locked onto 3I Atlas on August 6, 2025, it captured more than just the expected emissions from ice and gas. Using its near-infrared spectrograph NIRSpec, the telescope mapped dust and gas emissions around the object, revealing a vivid format of carbon dioxide, water, and carbon monoxide distributed about the nucleus. Among these standard comet characteristics, though, the data also included faint glowing patches that defied context, lights that appeared too steady, too directional, too self-contained to be simply scattered sunlight reflecting off random particles. Although mainstream reporting has not yet verified these lights as artificial, the growing chatter among some researchers and observers is unmistakable. What if there is something beyond the natural at play here? To understand the implications of these lights, one must first grasp how unusual 3I Atlas already is. As the third confirmed interstellar object, preceded only by 1I Oumuamua and 2I/Borisov, it arrived with a speed, orbit, and chemical signature unlike anything previously seen. JWST uncovered a CO2 to water ratio around 8, one in the coma, a figure that is among the highest ever recorded and far higher than in typical solar system comets. The implication was clear: 3Y Atlas formed in a radically different environment, where volatile ices and heavy radiation processing shaped its chemistry in ways alien to our backyard. Now, superimpose on that odd chemistry the detection of lights that seem to flicker, persist, and perhaps emanate from within or upon the object rather than merely from its dust halo. If these lights are genuine, whether caused by internal heat sources, reflective surfaces, or something else entirely, they raise profound questions. Could they signal internal structure rather than random ice sublimation? Is 3I Atlas merely a large chunk of cosmic ice? Or does it harbor a complexity far beyond expectation? Consider the potential origins of such lights. In a natural scenario, they might be due to subsurface heating. Perhaps 3I Atlas contains pockets of frozen gases that, when warmed by the sun, produce jets or plumes that glow in particular infrared wavelengths. JWST's mapping already showed unexpected distributions of ices and dust. For example, the 1.2 scattered light map revealed subtle structure in the dust coma near the nucleus. Those structures could, in principle, channel sunlight or internal heat in ways that produce localized glows. But the patterns being discussed go beyond mere jets or plumes. The lights were described as persistent and internal rather than fleeting and surface only. That suggests something holistic, perhaps a reservoir of heat or energy deep inside the object, or a reflective surface engineered to direct light outward. Should those possibilities hold any weight, the implications ripple outward. If 3I Atlas harbors an internal heat source, it invites comparisons with objects like moons in our system, for example, Europa or Enceladus, whose subsurface oceans are warmed by tidal heating. But 3I Atlas is not orbiting a planet. It is on a hyperbolic path, journeying from interstellar space. So how could it sustain such heating? Possibilities include a decaying radioactive core, early exposure to intense cosmic rays, or internal machinery of some kind. Even if machinery isn't the answer, the presence of internal heat in an interstellar object shatters simple classifications of such bodies as inert. It suggests icy wanderers can carry hidden energy reservoirs, which broadens our understanding of what interstellar objects might be like. Then there is the possibility of reflective or engineered surfaces. The sheer idea that these lights could be techno-signatures is speculative, but not without precedent in academic discussion. Scientists have argued that interstellar objects could be excellent targets in the search for extraterrestrial technology. If 3I Atlas indeed carries reflective surfaces that channel or emit light in ways distinct from natural reflections, then our definitions of comets and asteroids would need rewriting. Instead of passive ancient ice, we might face artifacts traversing the galaxy. Even if the lights are natural, their presence forces re-evaluation of solar system dynamics and formation history. Consider that 3I Atlas may have originated near a CO2 ice line, where carbon dioxide freezes at roughly the distance in a protoplanetary disk, where the material is cooler yet volatile processing occurs. The near star-forming environment could have endowed it with layered structures, frozen pockets, and atypical grain properties. JWST's detection of vast CO2 outgassing supports this scenario. The object is venting huge volumes of CO2 while water and CO remain comparatively scant. That alone challenges previous assumptions about the bodies roaming between the stars. Now couple that with mysterious lights and you have a specimen that isn't just scientifically unusual, it could be archetypal of a new class of interstellar entities. The dynamic of observing these lights is crucial too. JWST's observations were made when the object was still some distance from the Sun, but as 3I Atlas closes toward perihelion, its activity is likely to peak. The lights, if they follow patterns tied to activity, for example, when a region faces the Sun, or when an internal reservoir vents, might intensify, fade, or shift. That sets up a tantalizing scenario. We could witness in real time how an interstellar body behaves under solar heating, with surface and subsurface features responding. Every flicker of light may map to a physical or chemical process. The fact that JWST and other observatories such as Hubble Space Telescope and SphereX are coordinating observations adds power to the dataset. Zooming out, the implications for astronomy and planetary science are immense. For years, interstellar objects were treated as curios, rare fleeting visitors whose primary value lay in general statistics of origin and frequency. But 3I Atlas, with its odd chemistry and now lights, could shift them into a class of prime investigative targets. It reveals that interstellar bodies may carry signatures of formation, evolution, and even internal architectures that are far richer than once assumed. If internal heat or light emission is somehow common among them, our models of how small bodies evolve in interstellar space will need rewriting. For the field of astrobiology, the lights invite bold speculation. Whether the source is natural or not, the mere detection of persistent localized lighting opens the door to questions about habitability, complexity, and history. Could any such object harbor pockets of liquid, microenvironments, or even biological function? The conditions may seem extreme, but the universe is vast and has repeatedly humbled us with surprises. As the renowned researcher Avi Loeb has argued, interstellar objects may offer the best chance of detecting techno-signatures precisely because they venture into new systems from unexplored origins. The implications for humanity's place in the cosmos are profound. The discovery of lights on such a visitor shifts it from being an object of curiosity to a potential messenger. It asks us not just to look outward at distant stars, but inward at the vastness and variety of things between the stars. It presses on our understanding of what is possible. When we think of cosmic visitors, we imagine simple icy rocks or dusty debris. But here we may have something that is neither quite the one nor the other. A body shaped by processes far from our sun, carrying secrets of formation, trajectory, and perhaps even purpose. There is also a narrative of urgency. 3I Atlas is not lingering. It is swinging through our neighborhood and will recede back into interstellar space. Each hour of observation is precious. As it approaches perihelion then departs, its lighting behavior, coma structure, and activity will evolve rapidly. Scientists must act quickly to capture the evolution of these lights, whether they shift as the object is heated, whether they align with outgassing events, whether they fade as it recedes. The lights may hold clues about internal structure, composition layering, or energy sources. Observatories across the globe and in space are now racing to gather high-resolution imaging, spectroscopy, polarization data, and temporal sequences. In the realm of cosmology and galactic history, 3I Atlas may also invite reconsideration of population statistics. If such objects can carry internal heat sources or light-emitting structures, then the galaxy may be filled with wanderers far more complex than simple inert chunks of rock. The detection of light suggests we may have underestimated what interstellar objects can carry. That changes how we model the ejection, travel, and aging of bodies in interstellar space. Could some of these wanderers be relics of ancient planetary systems, having shed their host stars and transported complex architectures across the galaxy? If so, then every interstellar object could be a time capsule of other worlds. Moreover, the lights may help refine detection strategies for similar objects in the future. If natural interstellar bodies can emit or reflect light in distinct patterns, telescopes can be tuned to search for the telltale glows at infrared wavelength or transient flickers as bodies heat near other stars. The fact that JWS could pick up these lights at such a distance opens the potential for spotting other interstellar objects, not just when they sweep by, but earlier, enabling more detailed study. That would transform interstellar object science from ad hoc observations to planned campaigns. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the mysterious lights detected by the James Webb Telescope? We want to hear from you. Thank you for watching and see you next time.